Okay, we're going to talk now about inorganic nomenclature. We're going to talk about ionic compounds, covalent compounds, and acids. So, to begin, the very first thing you need to do when you're naming something is decide which type of thing you're dealing with. We're going to have ionic compounds, acids, and covalent or molecular compounds to work with. You can identify them because ionic compounds are made with a metal and a nonmetal, or they have two ions in them. Like you would identify those like an ammonium nitrate. Even though it has all nonmetals in it, they're ions, they're the polyatomic ions, so you would identify it that way. They may have more than two elements, meaning they have a polyatomic ion in them. Or they may have a transition metal, and you know because you know where the transition metals are. Acids are going to have an H on the front, or they're going to be called acid. That's how you identify them. And they can either be binary or oxoacids. We'll talk about both. Covalent compounds, we're only going to worry about binary covalent compounds, meaning they only contain two elements. And they will be made entirely of nonmetals. So ionic compounds, the way it works is you name the cation and then you name the anion. When you are writing the formula, you write the formula for the cation and write the formula for the anion and then figure out how to make the charges cancel out. So with these examples, we have sodium chloride. Sodium is the name of a sodium ion. So this is sodium metal, which is a solid, but then it's lost an electron and then it becomes Na+. So when I see the word sodium, I think to myself, Na+. I'm going to write that down with a tool that does that. And then I see chloride, and this is a little different than the element name. It has an "ide" on the end instead of an "ene," which is normally what's there, chlorine at the end. And that's because this "ide" is telling me that that element has now become an ion, and chlorine, because it's in the 7th column on the periodic table, will get a -1 charge. So I have Na+ and I have Cl-. Obviously, if I have a +1 and a -1, they cancel out, which is how I get the NaCl. That's my formula for my compound. Iron 3 oxide is different because now this one contains a transition metal. Transition metals are funny because unlike the representative elements, those elements that are in the first 2 and the last 6 columns on the periodic table, those are the representative elements. The transition metals can have multiple stable ions. Iron, for example, can be iron 2+ or iron 3+. So when we're writing the name of it, we have to indicate which one we're talking about. And what we do is we include a Roman numeral. Whenever you see a Roman numeral, you should recognize that that Roman numeral belongs to the metal and it tells you the charge. So when I see iron 3, I think to myself Fe3+. Because iron 3, that 3 is telling me the charge on the metal cation. I see oxide, and I know that that's a regular element, oxygen, and it has "ide" on the end of it because it's become an ion. Oxygen, its stable ion is 2-. So I've got an Fe3+ and an O2-. Now, how do I get these guys to cancel out? What I'm going to do is I'm going to find the lowest common multiple, which for 3 and 2 is 6, and then I'm going to multiply. So for iron, I'm going to need 2 of them to get to 6. Oxygen, I'm going to need 3 of them to get to -6. So that's how I end up with Fe2O3. 2 times 3 gives me the +6, 3 times -2 gives me the -6, and my charge cancels out, adds up to 0. Okay, then I have potassium chromate. This one is different because now it contains a polyatomic ion. We can recognize it because it has potassium, chromium, and oxygen in it, 3 elements. And I wouldn't ask you to name one that has 3 elements if it weren't a polyatomic ion. So we need to recognize that chromate, CrO4, is one of the polyatomic ions. When I see potassium, I think to myself, that's K+. It's again one of the representative elements. Its stable ion is +1. When I see chromate, I think that's CrO4 2-. And I know that because I memorized the formulas of the polyatomic ions. So now I have K+ and CrO4 2-. In order to make the charges cancel out, I need two of the, oh goodness, I need 2 of the potassiums right here. Totally clear now that I scribbled there. I'll point to it this way. Ding, ding, ding. Okay. 2 potassiums, that gives me +2, 0 for 2 minus, and it adds up to 0, which is what I want. All of my ionic compounds are going to be neutral. Okay, now, there's 3 kinds of cations that we can have. We can have monatomic main group elements. Those are the representative elements or the main group elements that I talked about. The first 2 columns of the periodic table, the last 6 columns of the periodic table. All of those guys are going to just have the charge that they have by having a noble gas electron configuration. Sodium's in the first column. It needs to lose 1 electron to become like neon. And once it does that, it's stable. So Na plus is a stable ion. Second, we can have a monatomic transition metal elements. These, you have to include a Roman numeral to indicate the charge because you can't tell what the charge is going to be just by looking at it because they make multiple charges. Finally, the third kind is the polyatomic ions. The only one that you guys need to memorize that's positively charged is ammonium, NH4+. So those are your 3 cations. You can have 2 kinds of anions. Either main group elements, again, these guys are just going to make the charge that gives them a noble gas electron configuration. And the name will be the root of the element plus "-ide". So, for example, nitrogen becomes nitride, oxygen, oxide, fluorine, fluoride, sulfur, sulfide. The second kind of anion that you need to be aware of are the polyatomic ions, and these you have to memorize their formulas and charges. I told you about Nick the camel. Ate a clam for supper in Phoenix. This is a mnemonic device you can use to remember what the 8s are. Polyatomic ions usually end in "ate" or "ite". There's a couple of exceptions, hydroxide and cyanide among them. But otherwise 8 or "ite", so you can recognize that it's a polyatomic ion that way. You count up here the number of consonants to get the oxygens, the vowels to get the charge. So Nick gives us nitrate. That's NO3 minus 3 consonants for my 3 oxygens, 1 vowel, 1 minus charge. This gives you nitrogen, carbon, chlorine, sulfur, phosphorus. That gives you those polyatomic ions. The other ones you just have to memorize. Okay, so now we put them together. There they are, polyatomic ions for you to memorize. A couple of things I'll point out real quick. Phosphate and phosphite are related. Notice they're exactly the same except the "ite" version has 1 less oxygen. That is always the case. If you have sulfate and sulfite, the "ite" version has 1 less oxygen. Okay? Same thing over here, chlorite, chlorate, perchlorate, also hypochlorite. These are related by the number of oxygens that they have. Per tells you it has a lot, hypo tells you it has a little, 8 has 1 more than ite. Nitrate, nitrite. So you can see if you know the 8s, that gives you a lot of the ites and the other ones that you need to know that are associated with that. We also have hydrogen sulfite or hydrogen sulfate. These have added an H+. So the charge has gone down by 1. It's HSO3 minus for hydrogen sulfite instead of SO3 2-. We also will call this bisulfite or bisulfate. So all the ones that start with hydrogen, like hydrogen carbonate, could also be called bicarbonate, like sodium bicarbonate that you use as baking soda. Okay, so there's relationships between these guys. You don't have to memorize all of them, but you do have to memorize a significant number of them. Get started. Okay, let's do some practice. We have here K2S. We're going to write its name. What do? We look at the thing. There's only 2 parts. There's a cation and an anion. This one is called potassium. K, so I write potassium. And then I see the S, and it's an element. It's not a polyatomic ion, so when it becomes a negative ion, it just gets "-ide and it added on to the end of it. Potassium sulfide. I have BaCl2. Barium is the metal there, the cation. Barium and Cl just the element by itself, chloride, all ending in ide, okay, because they are single elements. I have magnesium here, which just has the same name as the element that it comes from, magnesium, and then this is phosphorus as a -3 ion, that's phosphide. Oh goodness. Phosphide. Okay, there we go. Now, I have some that contain polyatomic ions. What am I going to do with those? I'm just going to name the polyatomic ions. So I look at this one, I see the cation is aluminum, so I write aluminum. And then I look at the anion and I recognize CO3 2- is carbonate. So I write carbonate. I just write the name of the cation and the anion. This is a cation and it's a polyatomic ion we had to memorize, ammonium. This is SO3 2-, which is a polyatomic ion we have to memorize. This is ammonium sulfite. I have a K, that's my potassium. And I have an NO2, I recognize that as nitrite. I have a CuS. Now I'm getting down to transition metals. Copper is a transition metal. I have to figure out what the charge is on the transition metal based on the anion that it's bonded to. So sulfur, when it makes an anion, it's always going to be S2-. That means my copper has to be Cu2+. So I'm going to write copper 2 sulfide. I got the charge on the cation by looking at the anion. Sulfur was 2-, so copper had to be 2+. Here I have manganese, Mn. Be careful because magnesium and manganese look a lot alike. This is manganese. Magnesium, of course, is not a transition metal. Manganese is. And then I have CH3COO- as my anion. I recognize that because it is acetate. So CH3COO-, I have 3 of them. That means my manganese has to be +3. So my name will be manganese 3 acetate. Last here I have Pb, which is lead. Lead is not, it's like a post-transition metal. It's not in the D block, but it still can have multiple charges. So now I've got to look at this carefully. It's O2, and you might be tempted to say, well, that means it must be lead 2 because there's 2 oxygens there. But if you remember, oxygen has a -2 charge, so if I have 2 of them, that makes -4. My lead actually has to be +4. So this is lead 4 oxide. Be careful with those. Okay, now name to formula. Aluminum oxide. All I do is I write down the formula for the cation, and then I write down the formula for the anion, and then I balance their charges. So, aluminum oxide. This gives me Al3+. Oxide is O2-. I'm going to balance my charges, finding the least common multiple. I end up with Al2O3. Magnesium fluoride. This is Mg2+. Fluoride is F-. I'm getting these charges from the periodic table, looking at what column they're in and where they have to go to be isoelectronic with a noble gas. Mg2+, F-, that's going to give me MgF2, the smallest numbers that I can use that balance the charge. Potassium nitrite. Potassium is K+, nitrite is N3-. I put those together, I get K3N. Sodium hydroxide. Sodium is Na+. Hydroxide is one of the polyatomic ions. It's OH-. My formula will be NaOH. Lithium carbonate. Lithium is lithium 1+. Carbonate is a polyatomic ion, CO3 2-. I have to balance the charge by having 2 lithium, so I have Li2CO3. And aluminum sulfate. Aluminum is Al3+. Sulfate is SO4 2-. I've got to balance the charges. So now this is a little tricky. I'm going to need 2 aluminums and I'm going to need 3 sulfates. So I do Al2. And now sulfate, because it's a polyatomic ion and I have multiples of them, I've got to put it in parentheses to say I have 3 of the whole thing, not just 43 oxygens, for example, if you didn't have the parentheses there. Okay, copper 2 nitrate. Copper 2 tells me it's Cu2+, that's what the 2 means. Nitrate's a polyatomic ion, NO3-. This gives me Cu, NO3, 2. Tin 4 sulfate. Tin is Sn, 4+, sulfate SO4, 2-. This gives me Sn, SO4, 2. Iron 2 chloride, Fe2+, chloride Cl-. That gives me FeCl2. There we are. Ionic compounds, done. Now, let's talk about acids. We have 2 kinds of acids. We have binary acids and we have oxo acids. Binary acids contain hydrogen and 1 other element, or it can be cyanide. Cyanide's a polyatomic ion, but it's a little strange. It follows the rules as if it were a binary acid. How do we name these guys? We're going to call them hydroblankic acid. For example, hydrochloric acid has hydrogen and chloride. Hydrosulfuric acid has hydrogen and sulfur. Hydroiodic acid has hydrogen and iodine. Hydrocyanic acid is HCN. It's the only one that's a little funky because it's got that polyatomic ion in it. Okay. There's something important I need to say. This is, when I'm writing the formula here, the reason I determine how many H's are here is based on the charge of my anion. Chlorine has a -1 charge when it becomes the ion chloride, and so it takes 1 H plus to balance out the 1 Cl minus. So I get an H and a Cl, and they are neutral. Down here, sulfur, when it makes an ion sulfide, will be S2 minus, so I need 2 H's to balance out that negative charge. That's how I decide how many H's I get. Oxo acids contain hydrogen plus a polyatomic ion, which generally also contains oxygen, which is why we call them oxo acids. In order to do this, we balance the charges to find the formula. For example, if I have a polyatomic ion like carbonate, CO3 2-, I would need 2 H pluses to balance the charge, H2CO3. Okay. The names are based on the name of the polyatomic ion. If the polyatomic ion ends in ate, it becomes ic. If it ends in ite, it becomes us. I like to remember this like attic-itis, like your attic is swollen. I don't know. Then you can remember that ate turns into ic and ite turns into us. So sulfuric acid comes from the polyatomic ion sulfate. Ate turns into ic. Nitrous acid comes from nitrite. Ite turns into us. Nitrous acid. Let's do some practice. Over here on the left, I have an H and I have a Cl. It only contains 2 things. Therefore, I'm going to use the rules for binary acids. Those are always going to begin with hydro. This is hydrochloric acid. I should note, when we're talking about acids, that means that they are aqueous. Hydrogen chloride is a gas. So if you see HCl gas, you need to name it hydrogen chloride. If you see HCl aqueous, you need to name it hydrochloric acid, because when it's dissolved in water, it behaves this way as an acid. That's true for several of these very small acids. Like hydrogen bromide, for example, you could have as a gas. Okay. HClO3. ClO3 is a polyatomic ion. It is chlorate. 8 turns into ic. So this is going to be chloric acid. Notice it's different. Chloric acid is very different than hydrochloric acid. You need to pay careful attention. Hydro means that it's a binary acid. H3PO4. PO4 is the phosphate polyatomic ion. So this is going to be phosphoric acid. H2CO3, this is carbonate. That's going to be carbonic acid. This is acetic acid because I have the acetate ion. You frequently see this written this other way, CH3COOH. This sort of tells us the way the atoms are connected and helps us to understand the structure better. Many organic acids, those that have a lot of carbon in them, contain a COOH group. Finally, here I have HF. HF is a binary acid, so it's going to begin with hydro. This will be hydrofluoric acid. Okay, hydrobromic acid, that tells me it's binary. I've got Br minus, so it's going to be HBr. I need one H to balance the minus. Hydrocyanic acid, this one's kind of a funky exception, but this comes from cyanide. This will be HCN. Again, one H because cyanide has a -1 charge. Nitric acid. 8 turns into ic, so this must come from nitrate. Nitrate is NO3 minus, so I'll need one H to balance the negative charge, HNO3. Sulfurous acid, us comes from ite, and so this must be from sulfite. Sulfite is SO3 2 minus, so this will be H2SO3. Phosphorus acid comes from phosphite, PO3 3 minus, so H3PO3. Acetic acid we did over here, so it's kind of cheating, but we can do it again. HCH3COO is one way you might see it, or like we wrote it over there, CH3COOH. You should also recognize COOH as a way that you can identify an acid. Acids, done. Let's talk about covalent compounds. Thankfully, these are the easiest. You'll be grateful because we're almost done. Covalent compounds, we're only going to have binary compounds. They have 2 elements. Those are the ones that you'll have to name. Because covalent compounds share electrons, as the name suggests, covalent, they're sharing valence electrons, they can combine in a lot of different ways. So we use Greek prefixes to indicate the number of atoms of each element. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. We generally put the less electronegative element first, and the pattern is we have a prefix, how many there are, the name of the element, and then the prefix for the second element, and then we finish with "ide" for the thing that is the more electronegative thing. Okay, let's do some other additional rules. You don't use the prefix mono on the first element. So SO3 is sulfur trioxide, not monosulfur trioxide. Also, prefixes ending with O or A get modified when you start something with a vowel. This would be tetraphosphorus decoxide, not decaoxide. It's not a big deal if you forget this. This one is more of a big deal. Okay, so let's do some practice. We have CO2. This one's easy. I have 1 carbon, so I write carbon. And then I have 2 oxygens, so I write dioxide. You know that one. This is carbon, and it has 1 oxygen. That is carbon monoxide. You also know that one. Notice I did not say monocarbon monoxide. That's because the first element doesn't get a mono, only the second element needs a mono. The first element only needs a prefix if it has more than one, like this one, P2O5. This will be diphosphorus pentoxide. SiO2 is silicon dioxide. SO3, sulfur trioxide. PBr5, phosphorus pentabromide. Ni3, nitrogen triiodide. This is fun because it's sort of explosive, just for reference. N2O4, dinitrogen tetroxide. Oops, tetroxide. 2 nitrogens, 4 oxygens. Pretty straightforward, pretty easy. Nitrogen monoxide, that's 1 N and 1 O. Dinitrogen monoxide, that's 2 N's and 1 O. Nitrogen dioxide, 1 N, 2 O's. Carbon tetrachloride, 1 C, 4 Cl's. Dihydrogen monoxide, oopsie, that's 2 H's and 1 O, otherwise known as water. Yay! That's a smiley face right there. Okay. Okay. Tetraphosphorus trisulfide. That's going to have 4 phosphoruses and 3 sulfurs. There you go. That's covalent naming in a nutshell. I believe we're done. We could do the iClicker quiz, but you don't have iClickers right now. So we'll finish here. Congratulations, you made it to the end!